All right, thanks everyone for coming. My name is Bryan Levin. I have a small company called Circona Audio that is basically doing research and development at this point. And over the last couple of years, I've been concentrating on remote control, not so much carrying audio over the network, but really controlling things in terms of volume control, input-output selection, things like that. So let's get right into it. All right, so one of the first things that I developed was essentially a new take on how to do volume control. Existing volume controls that use standardized remotes usually just have an up and a down button. What I ended up doing was having two speeds on a remote control to avoid acceleration. Instead of pressing a button and having it go through some curve, you basically have auto repeat at a constant speed, but you can choose what step size you want to use. For convention, I've used left and right buttons for 1 dB steps and up and down for 4 dB steps, just because it lets me make faster jumps up and down. I can zoom up and down quickly, and then I can make a left and right adjustment to get to the exact sweet spot. So that was a common theme, and whenever you see the plus keypad here, the up and down are the fast steps, left and right are the slow steps. And I'll probably get into that a little bit more later on. But that was one of the first concepts that I came up with, and I've been using that for about the last 4 or 5 years. And it's been fairly effective. The fact that it doesn't have acceleration, that you're not overshooting, you're not really fighting with your volume control, you feel more in control. And if something comes really loud, you can lower it very quickly. And if you need to find the exact sweet spot, the 1 dB or even a half dB will work for that. All right, so that's one concept. The other concept is infrared versus RF. Most of your usual consumer remotes are infrared, and it works great, and it's cheap, and it's affordable, and it works reasonable distance. Problem with infrared is that you can't get information back. You can push to it, you can send commands out, but you can't get. So being involved in the Arduino community, the XB, this radio right here, is very, very common. It's easy to interface with. It is a digital interface where you send 9.6 serial TTL into it. And if you have a pair of these radios, you set them to the same channel, and it's just a virtual wire. You get the same characters out. You set them both to 9.6 or 19.2 or whatever speed you want. And it's just an easy way of transporting serial digital data across the wireless network. It is not Wi-Fi, it is not Bluetooth, it is 2.4 gigahertz, but it's its own standard. So what I've done is I've implemented the XBs in pretty much every device here. Here's an HDMI switch with an XB in it. All of the devices have the XB in it, and it allows me to have remote control to device, or device to device, or later even a bridging into the IP network. So the XB network is RF, and the RF remote control, this is one of the examples, completely built from scratch, DIY. The RF remote directly addresses the other devices. So I've got a volume controller here, a preamp, and to show the steps, I'll go left and right, and that's 1 dB steps, up and down, 4 dB steps. You don't have to point it at it. You can go fairly good distance. It goes between rooms. And so the XB stuff is actually really nice. And when all of the radios are tuned to the same channel, the same PAN, the same personal area network, when one transmitter puts a packet on the network, they all receive it. And I'm actually using that to an advantage here, essentially poor man's multicast. So the XB network is your components and the remote control. If we wanted to include IP networking, you've got a phone or a browser or something else that you wanted to be able to control and manage these devices, you'll go through, at least for now, a Linux box, coming in over IP. It could be Ethernet, it could be Wi-Fi. Go into the Linux box, and now you've got a binding between an XB This is just a serial USB interface, goes into a USB port, looks like a USB device. And so a process here can listen and talk, and gateway back between these two. So that's sort of a story in having local and routable IP communications for remote control. Adding one more wrinkle to it, if we actually did want to use infrared, there is a way to do that. I've got a box here that will receive infrared, translate it back out to XB, and I could actually have this and the receiver off in a room together. It'll send XB out over the network, and these boxes can be remote, they can be behind cabinet doors, you don't have to see them. So if you really prefer infrared, there's a story for it. If you prefer front panel controls, there's a story for that. If you want to come in from browser type things, you can do that. And there's a way to come in from infrared. So pretty much all the kinds of connectivity are supported. Now, the handheld remote, I have it sitting on a Qi charging cradle, a triple coil charging cable. It's got a coil in the back. Basically, you can just buy these little coils, and it gives you 5 volts out. You lay the coil against the charging thing, and you get 5 volts. So I really didn't have to spend a whole lot of time on battery management or making things very power efficient. The use case that I prefer is just to have a switch on it, put it back in the cradle when you're not using it. I don't know if the camera can pick it up or not. It's kind of dim, but there's a red light here, and that'll turn green once it's fully charged. And I've been able to get a few hours of continuous use. And if you wanted to save the screen, there's a screensaver there. So you can make your adjustments, and then the screen will turn off. Okay, leave it back on. Let's see. As far as the user interface, this I'm actually kind of making it up as I go along. I haven't really decided what all the functionality would do. Currently, I just have a menu button to select mode pages. You can adjust input-output selection on analog, input-output selection on SPDIF, HDMI selection, and then volume control. I'll probably figure out a better use for these buttons later on, but currently in volume control mode, that's the big and the small steps. If we go to, let's see, SPDIF switch, I can basically select one of 2 inputs, or more inputs if I had more input ports. It will get the word clock from the SPDIF receiver chip, and it'll show you the sample rate. And you can name the ports. So I just named it by the media type, coax and opto. You could name it your DVD or your MP3 player or whatever. That's actually part of the value add and part of the concept is that you can take existing things like a switch fabric or an HDMI switch. An HDMI switch that I just bought, took it out of the box, added an interface to it, and now you have port names. If I go to the HDMI menu, video 1, video 3, video 2. So you can change those names, and then after some timeout, it goes back to showing clock, which is all configurable. Okay. What can be controlled? Currently, we have 2 existing options that you can just buy from amb.org. 2 relay controllers, a volume control, and an input-output selector. And I've got examples up here, so if you want to come up later on and take a look at them or try them. And when you turn the knob, you can actually hear the relays clicking, so that's the volume control. I've combined all of that in one box as a preamp, input-output selector, and preamp. But here I broke them out into 2 separate boxes. A box just to do I/O selection and a box just to do volume control. Now, this one is rotary encoder based. You can choose that style of input if you like. Or let me boot into another one. This one is a motorized pot. And you're not putting audio through the pot, it's just a control element. So it's the same style of display, but you'll notice that the pot moves at a different rate. And the pot is really just a control element. It lets you adjust it. It's really just getting a ratio of where you are. But what's different from a lot of the other motorized pot implementations is that the volume control command takes effect immediately, and the pot just shuttles over in the background when it can. So some of the other implementations I've seen, you actually have to be synchronous and you have to wait for the pot to actually get there. This one's different. All right, so that's that one. Let me go back to this one. Okay. Okay. So this is what it looked like when I first threw something together. I started with just some 0.1-inch proto board. I kind of like these buttons, these tactile buttons. You can kind of find where home is. You can feel the up and down. You can basically use it just by feel. So I've got the button keypad here, an OLED display. The Arduino chip is underneath. The XB module is down here. I will probably end up moving it more towards the top. A battery charger for the light poly battery and the light poly battery underneath. So I ran with that for maybe a week or so before I figured out some way of putting it into plastic. The second version, so the first one was fairly large. The second one, I was able to size reduce it quite a bit. And it's the same basic functionality. And in fact, because of that multicast nature, as I update the volume control here, they both update. I can come in through this one, and this will update as well as that one, or even from infrared, and they'll all update. Well, if I aim it at it. Okay. Speaking of which, just to demonstrate, not necessarily that it would be all that super useful, but just to demonstrate the idea that when an adjustment is made, a value is reported to the RF network. I've got some other devices. Comes up as a clock. There we go. So just as a demo, it's running in clock mode right now, but if I change the volume, it acts as a display, which means basically I can send messages to this thing. It's not really just a clock. In fact, it doesn't have any timekeeping in it at all. It uses a GPS sender that sends out time beacons, and I can add to the party. And this is just showing that one packet being transmitted and all of the receivers connected to the virtual bus receiving is free. Only one person can transmit it at one time, but the fact that the response time is actually very fast. I mean, if you look at the update speed here we can't overrun the rotary encoder, and even though it's RF wireless, it still keeps up. Come in with here. And at home, I have this display set up to show if an alarm has elapsed, or if I have new mail, or if I left a door open. Basically, a lot of IoT, a lot of Internet of Things. Sending a message to this device, or any of these others is fairly simple. So it's really the idea of taking the information from something, sending it out, and then defining which display devices want to show it, and possibly what kinds of information to show. This is a shot of what the XB gateway looks like. So this device right here will receive infrared and then send out the packets. There you can see it blinking. So when I point the infrared at it, it's receiving and it's sending it out over the XB. You can, Well, let's see. I have an infrared receiver, infrared transmitters, so you can remap one infrared code to another. Yeah, in theory, I could receive XB and I could send it out on the blaster as well. It could be bidirectional. In fact, I might actually implement that. That's a good idea. One use case of remapping is that I've got a TV at home, and the only control on that TV I care about is power on and off. And I use my remotes for all the audio system. So what I did was I mapped one of these spare buttons to a code on my home Vizio TV, and I just received the IR, blasted out to a different IR code, and now I can throw that remote into the drawer, forget about it once I've gone through learning mode, and it's just extra utility. So if you needed to remap IR or remap XB, this is a possibility. Some shots of what the Qi coils look like, and I did show these out. You can buy these for about $10 on eBay and Amazon. It's a very, very thin wafer, has a USB connection on it, and so you can just slip this into an existing phone or something. It's extremely thin, and it just gives you 5 volts. If you connect it to Qi, it'll simply give you 5 volts. So it's easy. It's $10 or less, very thin. There's no reason why you can't implement Qi charging and Li-Poly battery charging. You simply just buy a little module that handles all the right kinds of charging curves, and it's foolproof. There's just nothing you have to do with it. So some of the boxes that I do have for management, like I said, there's a SPDIF switch. And if I go to one of the mode pages, I could select the input, or I could use the front panel. And let's see. A relay attenuator. Basically, it was a version of this, or this one right here. And I'm kind of big on independence of the user interface and the back-end engine. Some people like rotary encoders, some people like motorized pots, some people like arrow buttons. The way I've developed the code is that it's kind of independent. You can choose your user interface style, you can graft it into the device, and you can come in via multiple ways as well. So there's really no specific religion. You can pick whatever style of user interface you like. Even for the display, you can choose the LED displays, if you wanted to, a NIXI display, LCD displays, OLED graphics. So independence on the display, independence on the input type, trying to keep things very generic. And this I did kind of demonstrate where they always stay in sync. So you're not going to go to one, change it, have the other one be out of sync. So that was, it was fun to do, and I thought it was important. You don't want to come in via one way, have this one be out of sync, and then touch it, and then the volume just changes quickly. And it's also very important for the motorized pot. That was the reason for the motorized pot, so that if I change the volume out of band, the knob will at least always reflect, as long as it gets there, the current value. All right, and then clocks. So along the, on the RF network, I've got control messages going back and forth, but I also wanted to have time as well. And so I've got a small box here. It turns out that it's actually very inexpensive to buy GPS modules these days. That's a $15 U-Blocks GPS module, gives you 9.6 serial out, and it gives me the exact time, locks within just a few minutes. So what happens here, let me show how the time stuff works. We have one time master, and we have multiple clients, and all of the clients have no local clock, no crystal, no idea of what time is. If I turn off the master and I reboot all the clients, Okay, so we're simulating VCR mode, if you remember that. Oh, let's do the switch as well. All right, all kinds of blinking stuff here. So what's happening is that they're sending out a request on the XB network saying, I need the time, and they send it out every 5 seconds. If I start the time server, okay, we got fed. So we have the time, and there's the time. At this point, I could actually disconnect the time server, and the only real downside to that is that every 5 minutes, it sends a new update. All of these clocks are running software clocks, and they're going to drift a little bit over time. So every 5 minutes, I send out a new update. They receive the same packet they get when they ask for the time. And 5 minutes seems to be a good time, and it really just keeps everything in sync. Okay. And the last thing that I can talk about, depending on how much time I've got, is what happens when you cross the streams. And I've already kind of done a demo of that before. When you basically have the same network, I've got the clock sitting on the same PAN, the same personal area network ID, and I happen to send out volume control changes. I've written code that decodes that and displays it in whatever way makes sense for the device. This is an alphanumeric display, so it can say vol, the number, and then the dB. The Nixie clock can really only do numbers. And it's interesting. What it's doing right now is cathode poisoning protection. You have to do that. Go look it up. But yeah, basically, when it starts doing this little dance every so often, it's to avoid some of the unused digits from showing. Actually, I can probably even show it. If you look at the 6, the bottom, a 6 is not normally occurring in a clock on that digit, so it's a little bit weird. The 8 is a little bit weird. So that's what, just as a side issue, what cathode poisoning looks like. So if you cycle through the digits, it's supposed to protect against that. So it's not necessarily that it's the most practical thing to send the volume control or other state changes to clocks, but it just shows that you can. You can send messages from machine to machine, from remotes to machine, from the IP network, and you basically, all these boxes can choose to action those packets or just ignore them. It's all open source. It's all open source hardware and software. I will be posting the source to my GitHub account once things are at a stable base level. But the whole idea is that what I've done may not be exactly what you want. And you pull down the source, you pull down the schematics, you change it. The Arduino system is very effective, it's very cheap, it's easy to get into, no licensing costs, no real hardware costs to get started up in an Arduino. And so pull down the sources, build up a test system, and modify it as you go. Change the display if you wanted to send the output of the HDMI switch here, or if you had an alarm, a kitchen alarm, or you left the garage door open, whatever, you could have a message that goes to your display. So that's about all I have for this short presentation. I've got a lot more information about it. I can talk about all the details if you want. I've got a table just around the corner. But any questions at this point?
Have you thought about putting the GPS into the remote so you never lose the remote?
I have thought about putting a beeper in there so you can send a beep signal and you can find the remote. That's definitely planned. GPS in the remote, GPS is going to consume power. You may not be able to receive GPS where the remote is sitting. And so that's actually a design, an intentional design detail. So by having GPS in one box and then sending the XB information across your entire house, well, where I have my clocks, I might not be able to get GPS reception. So I only have to have one GPS receiver, maybe put it near a window, near the best place to get it, and as long as I can receive XB anywhere in the house, all the clocks will be in sync, they'll all be updated, daylight savings time changes, they'll all be in sync with that. And if you have these clocks all over the house, if there's a message waiting, if there's new mail or some alert that you need to be aware of, it could be sent to the clocks in different rooms or in all of the rooms. So that's actually a design detail that was intentional. The GPS time master as one box and all the time consumers as separate boxes. Other questions? Yeah?
What's your favorite display?
These days, I really like this alphanumeric display because it's very fast. LCD displays tend to update somewhat slowly, but here it's just 8 characters. They come in groups of 4, and it's I²C running at either 100 or 400 kilohertz, and it's just very, very fast. And it's very easy. It's 4 wires, plus, minus, clock, and data. The Nixies are cool. They require high voltage, and they require a lot of extra care. These displays, this is kind of an old school dot matrix. It does hex and it does 0 through 9. So I really can't say dB or anything on it, but I kind of like the dot display. It looks a little bit different. I don't have any examples. Yeah, I have an LCD here, but I don't have it turned on. And this one actually is a fluorescent version of the LCD. So yeah. And then finally the OLED display. These OLED displays are like $10. And you can get them in white or blue. This is a white one behind an orange filter, so it gives me sort of an amber look. Other questions?
The volume control information you send across the network, that's always an absolute volume.
Oh, no, not necessarily. So let me see if I can get a terminal session going. I'll actually show you what the protocol looks like. There we go. Let's see. Restart. Yeah. All right, so yeah, since we have a little more time, let's talk about this. The protocol is in pure ASCII. It's simple. It's just a few characters. And I followed the GPS style sentences where the first character is a $, the payload is in the middle, you have a star character, and then 2 characters in hex for the checksum. And that guarantees that if I have corrupted packets or dropped packets or some kind of an error, we're not going to process some bizarre wrong number. We're only going to process valid entries. Now, these things just occurred. That's my time beacon. So TB is time beacon, and then that long integer is Unix time in seconds since 1970. That's absolute. And that's just showing the idea that we're sharing the same network. Now, as far as absolute versus relative, infrared remotes can only do relative mode. And so if I hit up or down, VC a -4 or a +4, VC volume control, -1 or +1, but you see the absolute value comes back. So if I'm changing the volume control, it's just, see, here's an example of corruption. Sometimes you get garbage packets, and if you didn't have the checksum, you might process some weird number and it'll just turn really loud on you. You don't want that. So here's absolute numbers. That's the actual dB value. And if I hit 1, what happens? It says, give me 4 dB higher. We were at -34. There's an implied minus sign there. And what happens is that I sent a relative request in to the IR gateway. It doesn't, obviously the infrared remote doesn't know the current value. The box itself knows the current value. So the gateway sends in, move up by 4. He knows his internal value. He reports back, my new value is 30. And he sends it twice just to make sure that if there's one collision, you'll get the second one. What that does is it gives all the other receivers an opportunity to now synchronize with the current value. And so if you want to come in relative, you can do that. If you want to come in absolute, you can do that too. Oh, and so let me show this. So when I power on the remote needs to know what the current value is because it wants to run in absolute mode. So when I power on the remote, it sends out a query, volume control ? What is the current volume? It responds back with a 30, and then it updates the display. Let me power it on once more. It starts out with a row of asterisks saying, I don't know what the value is yet, and then as soon as it comes across, he updates it. Okay, and it was fairly quick. And the same thing can happen if you change the order. So if I disconnect the preamp and I power it on again, it announces the value. So there are, and there's a mistaken printf still in my code, which I need to fix. So that's one area of the protocol. Let's do some more. If I go to a mode page and I select analog inputs, AI, analog input, 1, 2, etc. If I wanted to change SPDIF, DI, digital input, and for some reason I just chose C for coax, T for toslink, port 1 and port 2. But this is all user definable, and I just kind of threw this protocol together. It's not heavily thought, but it seems to work. For HDMI switching, HI, and then the port number. And let's see. And then just the updates from the volume control itself. So that's the protocol, and it's easy to debug. What I'm doing is I just have one of the XBs on a serial port, and it's sitting there listening to everything that's going on. If I am not generating the right code, or if I use the wrong variable name, I'll be able to see it. So this is like a poor man's sniffer, and by choosing ASCII and making the values directly literal, it just makes it easier. It makes it easier to see, to debug. And the interesting thing is that it's not all that slow. It actually keeps up fairly well. This rotary encoder, you really can't even overrun. Turn it as fast as you want, and the fast displays all keep up. So that's what the protocol looks like. It's not advanced, it's not standard. The only thing that's standard is the GPS style sentences with the $, the variable name equals value, and then the star with the checksum. And there's yet another time beacon. Oh, so let's do a client boot. So if I reboot one of the clocks, there we go. It says time beacon ? What is the current time? And then the master will respond with the current value. And again, because it puts the packet on the virtual network, once he sends it out, any clock who's on that network can now synchronize immediately to it. So you get a free synchronization just by booting one of the clients. So, yeah.
Do you have printed circuit boards in the works?
Some of them. We have, through AMB's website, amb.org, we have the volume control, the LC Arduino, the main motherboard. The rest is all hand-wired. So, I mean, it's all perf boards and hand-wired stuff. It's all completely prototyped. But once it gets to the point of being steady state and I'm happy with the performance and the functionality, yeah, we'll do PC boards. Yeah.
I don't know if you're familiar with the Logitech Harmony Hub, but it seems to me that would be the most useful application of this, to have a Linux box that is far more intelligent than these boxes you have now, that the remote can put into different states. Like I want to control this device, or I want to perform this kind of activity, meaning that this activity requires these inputs and these outputs, etc., and then have it connected to an IR gateway that can control all the devices in your home theater, and have the OLED display in the remote show at the top what activity you're now in, and have menus where you can go to different activities. I mean, that would be infinitely more useful than all these little narrow niche special purpose boxes. Is anybody working on that kind of a generalized network?
That I don't know. I tend not to really get involved in commercial vendor stuff. All this stuff is DIY, and it's all stuff that I can control. If I needed to communicate with that, if it has the Linux box integration, that might be the way of joining it, where these can be producers and consumers, producer of commands, consumers of commands, and if you needed to gateway to that control system, probably the Linux box would be a way of mapping them back and forth.
No, I'm not saying you should gateway to Logitech, but it should be a replacement for Logitech. The Linux box program to do everything that Logitech is doing.
Right, right. Right.
It's just tedious.
Yeah, right.
Yeah,
All that stuff exists and has for years.
I mean, one of the advantage of the Linux box is,
Go look up LIRC.
yep, yep. Yeah, the Linux box would give you scriptability. So if you basically wanted to send out commands, do a test, get a value, branch based on that, because the RF remote allows you to get values. What is the current input? Am I optical or am I coax? What is the current volume level? Am I muted or am I unmuted? With IR, you can push values across, but you can't get values. So you can actually do intelligent scripting if you can fetch things, see the current state, make decisions based on that, and then maybe reprogram other things. One thing I don't have working yet that is planned is a scene mode or a macro mode where you might just say, I want to watch TV. And you press the button and it sets everything up. It might set up the SPDIF switch and the HDMI switch and the preamp. It might even check to see if the TV is on, and if it's on, turn it on. That's the advantage of being able to do a get as well as a set. So the Linux box with, for example, Python would give you a very, very easy way of scripting things. And really, you could just send out these commands. If you didn't even need to do any gets, you just wanted to send out commands to things, you could really just have a flat ASCII file, cat that to dev T2I USB 0, and it would just send the commands out to the various devices.
The way your network scheme works, you don't have a single master control with slaves.
Correct.
Any point in the network can receive or transmit asynchronously. Do you have any mechanism in there for collision detection?
For collision detection, just the exclusive OR checksum. So if every single packet that comes through is checked, and you just drop the ones that have collisions. There isn't support for relays or routing or meshing. It's really just a flat network, and they all need to be able to see each other. But you definitely do need the CRC protection, because imagine if a bit error came through and it set your volume control to 0 to no attenuation. So it's obviously really important. That reminds me, another thing to talk about, this is a very thin network. There's no authentication, there's no security, there's no access control. This will be added over time, but the idea is to start very simply. Learn enough about it, see how it works. These variables are basically flat across boxes. That's not going to scale. So what I'm going to do is add destination and source addresses to the packet, and that way I can say VC, volume control on this box, instead of volume control on this box. So a way of instancing the boxes. Currently that's not done yet. Rather than start with a really complicated bit of code, start with it simple, learn about it, see how it performs, and then add extra complications over time. So that will be supported. I'll probably have permit and deny access control stuff. With XB, one of the neat things about the XB radios is that they do have encryption built in if you want to turn it on, and you can create pairings. So if that's important, you can do that. XB is also fairly short distance, so it's very unlikely that your neighbor is going to really interfere with you. This protocol is definitely not standard yet, maybe never at all. So it's unlikely that anybody's going to know what this stuff is to intentionally send something into JAMU. But you know, security and access control is important. It will be dealt with at some point, just not there yet. Oh, and there was also a question about why not Wi-Fi or Bluetooth. Those tend to be more attack vectors. There tends to be more people trying to hack your network with standard Wi-Fi and with Bluetooth. I haven't heard of anybody spending a lot of time trying to hack XB or Zigbee. Again, it's short distance. You can protect it in some ways, but it's not a super common protocol, and so people tend to just ignore it and you know, let it pass by. If it ever gets really, really common and popular, then yeah, some protection is going to be needed, but currently we just keep it simple.
Okay, so if a client receives a packet that flunks the 6 does, there's no feedback mechanism.
Correct, correct.
So he can't even tell the sender to resend.
Correct, correct. Right, right. That I did intentionally. you can have a balanced protocol of request and response. So if you send a request in and it wasn't received or it was corrupted, you'll know it because you didn't get a response or you got a negative response. Problem with that is that it doubles your traffic. So I've got to send in a request, I've got to get a response. You saw that there's one sender and multiple receivers. If there was 50 receivers and they each had to act the packet, that's not going to work so well. So I tried this style of sending some important packets twice and overlaying a volume change command of go to 50 and go to 50 doesn't hurt. So I can send it 2 times, 3 times, whatever. It doesn't take a lot of extra time. There's no latency issue because there's no response required. So it was an experiment to see if this can be made to work. It's not proper networking, but it does seem to work. And you simply just drop the packet that has an error in it. And if you start running into issues with a lot of drop packets, you just do more multiple sends. At some point, I might have to do a request response or maybe extend the protocol. But so far, just haven't had to. Other questions? Okay, so thanks for attending. And if you have more questions or if you want to see more specific demos, feel free to come by. My small demo room is just around the corner. So thank you.